Hi everyone, this video is designed in two parts. Part one is designed to show you what the different axes of a graph are and why we draw graphs in science. And part two will show you how to actually draw a graph and use it in your oral presentations during the lab. So let's get started. So the first part shows you how to actually draw a graph. If you look on the left-hand side, you'll see that each graph has two variables, one being the dependent variable and the second is what's referred to as the independent variable. I've also defined what each one of these variables are for you. The independent variable is the variable that is actually manipulated by the person doing the experiment, in this case the researcher. The dependent variable is the variable that is actually being measured by the experiment. And the way you graph these two is on an x and y axis respectively. In other words, on the x-axis down the bottom, you've got the independent variable. And on the y-axis, we graph the dependent variable, the variable that is actually measured. So let's put this into some type of context in a hypothetical experiment, and then from that we'll go to part two of the video, which will show you how to actually draw the graph. Here on the right side of the screen, you'll see that this is a hypothetical experiment. You're basically a scientist and you want to develop an experimental drug. And the drug should be designed to decrease cholesterol levels in different patients. So you start off with 15 different patients, and for each of those patients you have 3 different treatments. Treatment number 1 is a placebo, meaning that they ended up getting a sugar pill instead of the actual drug itself. Treatment number 2 was a low dose of the experimental drug, and treatment number 3 was a high dose of the drug. So you have 15 patients altogether, numbered 1 through 15, and each of those were randomized into different treatments, either treatment 1, treatment 2, or treatment 3. And what you can see is that each treatment had an equal number of patients. And if you add up the number of 1s, 2s, and 3s in this column, what you'll find is that there are 5 treatment 1s, 5 treatment 2s, and 5 treatment 3s. For each one of these patients, you took an initial blood sample to measure the initial LDL level, and then after the drug was administered for 24 hours, you took a final blood sample. And what you're looking at in this experiment is the ability of the drug to decrease LDL levels. So a good drug will decrease the level more than a low dose of the drug, for example, if that is in fact if the drug worked. So you're looking for the maximum amount of decrease. So how do you go about drawing the graph? You can do it a number of ways, some more effective than others. One way of doing it is to make the independent variable all of these patients. The problem with doing that, however, is that each patient had a different treatment. So a better way of drawing the graph is to make the independent variable treatment, this column here. And therefore you will only have 3 of these treatments, treatment 1, 2, and 3. Because you want to compare the initial as opposed to the final LDL level, what you're looking at is the difference between those two. So for each one of these treatments, it's a good idea to summarize these data in the table and compare the before with the after, and only measure or graph the change between the final and the initial. I've taken the liberty of doing that, and if you do that for each one of these treatments, this is the table that you come up with. And you can see that it's much simpler than the previous table. You have the before data in this column or row, and in this row you have the after data for each one of treatments 1, treatment 2, and treatment 3. So treatment in this case is the independent variable, and the before and after measurements are the dependent variable. So that's the end of part 1. Part 2 of the presentation is going to show you how to draw a graph using Excel. So here's my Excel presentation. Instead of a title slide, I'd like to embed a title and content slide. So we'll get rid of the first slide like that. And we need to put in a graph. So how do we go about drawing the graph? With the new version of Excel, this is straightforward. All you do to insert the chart is to click this icon, left click the icon like this. And once that's done, you have to choose the type of chart you want. In this case, I want to choose a column chart. And once that happens, Excel automatically opens. And the Excel document is divided into columns like this, B, C, and D, and rows 2 through 5, each one of the rows being categories. So these are the independent variables. Now, I only have 3 treatments, so I can get rid of category number 4 fairly easily just by deleting it. The categories shouldn't be called categories, they should be called treatments. So we'll go ahead and just double click on this and change it to a number, in this case number 1. Treatment 2 for now, we're just going to call 2, and treatment 3 we're going to call 3. And when you do that, look at what happens over here on the x-axis of the graph. It's automatically changed in Excel. The graph says series 1 through 3, but that's incorrect because we only have a before and after. So what I can do is get rid of column D. The reason for that is because we don't have a series 3, we only have a before and after, and series 1 will be the before measurements, and series 2 will be the after measurements. And again, they're changed over on the right hand side of the graph automatically. So now let's put in our data. This is the table that I showed you initially. So instead of 4.3, we can just go ahead and start to change our data now, which is what I'm going to do. Coincidentally, you'll note that all of these 3 treatments, the before number was exactly the same as it was for the other ones, 224. So now, here's the graph. One thing that Excel does is put these horizontal lines in. You can delete those simply by clicking on it once and then hitting the delete key on the keyboard. Decrease the size of the graph a little bit because we want to put both an X and a Y axis on here because axis labels are important. So we'll center it like this. And then we'll simply go ahead and put an independent variable label on here. Just left click and that label will be treatment. We'll center it a little bit like this, and 1 on the y-axis or the dependent variable as well. This time it'll be LDL levels, and don't forget the units in milligrams per deciliter. Now, if you want to rotate it, very easy to do. See this little green button? Just rotate it, hold down, mouse click, and rotate it like this. It's very, very easy to do. Each graph has to have a title, so we'll call this cholesterol drug study. And here is your completed graph. Very easy. Treatments 1, 2, and 3, the before in blue, the after in red. A good graph, you should be able to distinguish the data within about 30 seconds. So go ahead and see if you can tell me which treatment worked the best to lower cholesterol level. That's right, treatment 3. Look at that. So what we've done is gone from this complicated graph over here, or table. Look at all these data that you started off with, and you've made a simple graph from it. And that's the point of a graph, to summarize data. Before I go, I'd like to mention one final thing. You're required to, in the week before the oral presentation, to put a presentation together in PowerPoint. Say that you make a graph and the graph looks something like this, but these aren't the real data for the graph. And that's what your lab instructors are going to suggest that you do. So what do you do when you actually gather the data during the class time and have to change these columns, the blue as well as the red? How do you pull up Excel again and change these fake numbers to the real data? Very simple. You open up your presentation in PowerPoint. If you only have one button to click on a Macintosh, it's simple. It's the control left click, and when you control left click, it's the same as doing a right click on a PC. Go to edit data, and it doesn't matter whether you choose the blue or the red column to edit the data. And when you do that, the original Excel spreadsheet that you had pops up. And all you have to do to change any of these data is go ahead and get rid of the original data and change it on your Excel spreadsheet. And look what happens now. On the PowerPoint presentation, the data change automatically. So that's how you go about putting together an old presentation. If you need any help, simply ask your lab instructors. So I hope this video has helped you out, and good luck.